All right, everyone, welcome back. Ready for another deep dive.
Always ready to dive in.
Well, today we're heading straight to the center of our galaxy.
Sounds exciting. What are we looking at?
We're focusing on Sagittarius A, the supermassive black hole they call the Milky Way home.
Ah, yes, Sgr A, a fascinating object.
Absolutely. And we've got some incredible new data, fresh from the James Webb Space Telescope.
The JWST, wow, that's going to give us an incredible view.
Exactly. This isn't just your everyday space observation. This is about understanding the very forces that shaped our universe.
The fundamental forces at play around a black hole. It's mind-boggling.
It really is. What's so amazing is that we're seeing Sgr A in a completely new light, literally.
Literally, how so?
Well, the JWST, with its incredible infrared vision, can see through all that dust and gas that normally blocks our view of the galactic center.
Oh, I see. So we're getting a much clearer picture.
A clearer picture than ever before. And what it's showing us is, well, mind-blowing, to say the least.
Okay, you've got me hooked. Tell me more.
Sgr A isn't just sitting there passively. It's putting on this continuous light show with flares and flickers that the JWST observed over 48 hours.
Flares and flickers. So it's active. That's not what I expected.
It's active. Imagine a cosmic fireworks display, but instead of gunpowder, you've got gravity and magnetism at play on a scale we can barely comprehend.
Wow, that's a powerful image.
It is, and it's not like other black holes we've observed, which tend to have, more predictable outbursts. Sgr A is constantly changing. It's a real cosmic party animal.
A party animal. I like that. So what's driving all this activity? It can't be as simple as someone lighting a match out there.
Definitely not. Scientists believe this light show is coming from the accretion disk.
The accretion disk. Ah, that swirling vortex of matter being pulled into the black hole.
Exactly. It's like a giant cosmic whirlpool where things are getting superheated and compressed as they spiral inwards.
Okay, I can picture that. But what else is going on in there? I mean, what could explain those flares we're seeing?
Well, there's this phenomenon called magnetic reconnection.
Magnetic reconnection. That sounds intense.
It is. Imagine you have two incredibly powerful magnets and you twist their fields together. Eventually, they snap and realign, releasing a burst of energy. That's kind of what's happening in the accretion disk around Sgr A.
So these giant magnetic fields are constantly twisting and snapping, creating those bright flares.
Exactly. It's almost like a cosmic light switch being flicked on and off by these magnetic fields.
Wow, I never thought about it like that before. But wait, there's more, isn't there? You mentioned something about a time delay?
Ah, yes. This is where things get even more interesting. The JWST has actually detected a time delay between different wavelengths of light coming from Sgr A.
So the different types of light aren't arriving at the same time. Interesting.
It's like the light from those flares is taking different routes to reach us. The infrared light, for example, arrives a bit later than other wavelengths.
A time delay. That's got to tell us something important about what's happening near the black hole, right?
Absolutely. This time delay suggests that the light isn't coming from a single point. It's originating from different regions around the black hole, with some light taking a longer path to reach us.
So by analyzing this time delay, we can begin to map out the structure of the accretion disk itself.
Precisely. And the more we understand the structure of the accretion disk, the better we can grasp how matter falls into black holes and how those incredible jets of energy we see in other galaxies are generated.
It's amazing how much information we can glean from something as seemingly simple as a time delay. This research from Farhad Yousafzadeh and his team, published in Nature Astronomy, really showcases the power of the JWST.
It really does. It's like having a brand new window into the universe, allowing us to study black holes with a level of detail we never thought possible. And this is only the beginning. Who knows what other groundbreaking discoveries await us as we continue to observe Sgr A with the JWST.
It's an exciting time to be studying black holes, that's for sure. But let's bring it back down to Earth for a moment. What does all this mean for us here on our little planet?
That's a great question. I think for me, it's a reminder that even though black holes are incredibly massive and distant, they can still teach us about the fundamental laws of physics that govern everything around us. It's like looking back in time to understand how the universe evolved and how space-time itself behaves.
Beautifully put. And it underscores the importance of continuing to explore and learn about the universe, right? There are still so many mysteries out there waiting to be unraveled.
Absolutely. Who knows what other surprises Sgr A might have in store for us down the road? Maybe even a clue to the ultimate fate of the universe itself.
Now that's a thought to ponder.
It is. And on that note, we'll wrap up this deep dive. Thanks for joining us. And until next time, keep looking up.
And keep those questions coming.